Experiment 3. Measuring gravitational acceleration. The objective of this experiment was to investigate the functional relationship between height of fall and falling time, and to determine the acceleration due to gravity by studying the motion of a freely falling body. Here are the apparatus used in this experiment: a pendulum ball, a string, and a retard stand. This was our procedure. Step 1. We tied the string to the pendulum ball. Step 2. We measured 20 cm of string that will be used. Step 3. We tied and hung the pendulum and string on the retard stand. Step 4. We pulled the pendulum at a 30-degree angle and let go. Step 5. We recorded the time taken for pendulum to make one swing. Step 6. We repeated steps 2 to 4 using string length 40 cm and 60 cm. This was our results. Because gravitational acceleration on Earth is constant, the distance an object falls is proportional to the time spent falling. The increase in length of string caused an increase in the time it took for the pendulum ball to make one oscillation. Had we used a falling sphere apparatus consisting of release unit, impact switch, digital counter, 4 decades, support base, right angle clamp, plate holder, meter scale, support rod, connecting cord, and ball bearing, we would have made for a much more accurate reading to support our hypothesis. Possible errors made in this experiment is human error. When measuring the period per oscillation, timer was stopped using human visual instinct. Using a sensor would have resulted in a more digitally accurate reading. In conclusion, the functional relationship between height of fall and falling time is that it is directly proportional, and that the acceleration due to gravity of a free falling object is determined by its mass or distance between gravitational center of object and Earth. Experiment 4. Frictional force. The objective of this experiment was to determine the coefficient of static friction of different surfaces. These were the apparatus involved: spring scale, a wooden block, a string, and 50-gram masses. This was our procedure. Step 1. We measured the mass of the wooden block. Step 2. We attached the spring scale and the wooden block with the string and made sure the rubber side of the block was facing downwards. Step 3. We placed a 50-gram mass on the wooden block. Step 4. We slowly pulled the string and recorded the spring scale's reading once the block started to move. Step 5. We repeated step 4 until 3 trial readings were obtained. Step 6. We added another 50-gram mass on the wooden block and repeated steps 4 to 5. This was repeated until a total of 500-gram mass was on the wooden block. Step 7. We repeated steps 2 to 6 but made sure the rubber side of the block was facing upwards this time. This is our results.
The coefficient of static force for rubber surface against the table is higher compared to wooden surface against the table. This is because rubber is a material that causes high friction when it slides across a smooth surface. More force will be exerted on the rubber surface compared to the smooth wooden block surface, which will cause a resistance in the block movement. Experiment would have been improved had we used a digital spring scale for a more accurate reading. Possible errors in this experiment is a parallax error due to difficulty in properly observing the spring scale, as the reading was constantly changing and the spring scale was in motion during observation. In conclusion, different materials have different coefficient of static friction, which will affect the value of frictional force exerted on the surface when it slides across it. That is all from us. Thank you for watching.